Thanks for joining us for the interview portion of the Data Speaks competition created in partnership with RFG 2018 and Sequent. I'm Nicole Doucette, a Science Communications Specialist with Sequent, and I'm joined today by Xueya from the University of British Columbia. Welcome.
Hi.
Hello. All right, so
Hi, everyone.
I'm going to read out your original abstract title.
Yeah, sure.
Which was the characterization of ultramafic mine tailings reactivity for carbon capture, utilization, and storage. So what is your revised non-specialist abstract title?
So it's assessing the potential of mine waste for reducing atmospheric CO2, which is a new solution for climate change and global warming.
Awesome. So what question are you trying to answer?
So basically the motivation of my research comes from the fact that increasing atmospheric CO2 level right now has caused many problems around the world. So mainly what we see is global warming and climate change. And mine waste are these very fine materials that are leftovers after ore has been extracted or valuable minerals have been taken out. So there are these fine minerals that we found that have the reactability that they can react with atmospheric CO2. So, and then what happens is that these mine waste materials are highly variable in this chemical component. So what I'm trying to figure out is basically what is the optimum chemical component that is going to promote the most amount of carbon dioxide from the atmosphere being captured, utilized, and stored.
Great.
Yeah.
So what concept then does someone need to know to understand your research?
Not so complicated, actually. Only two. So number one is carbon mineralization, this idea. So it's basically that you capture carbon dioxide from the air and then you inject it into, let's say, a mine waste facility, and then you allow the CO2 to chemically combine with these mine waste, which are high concentration of, like metal ions, such as magnesium, because it's more abundant in mine waste material. So, however, and then this process is followed by like a precipitation or like a formation of a carbonate mineral, which is a permanent storage of CO2. However, to avoid the high cost of this process, we are only targeting the very highly reactive and surface attached, these very easily extractable metal ions, metal magnesium, which we refer as labile magnesium. And the amount of these labile magnesium basically equals to the amount of carbon dioxide that you can capture from the atmosphere. So understanding the idea of labile magnesium and carbon mineralization is what's important to understand my research, basically.
Great.
Yeah.
And so what role does data play in your research?
Well, I do experiments in a lab, so I collect data from experiments, basically. And so some preliminary data has shown that the amount of these very reactive metal ion magnesium, they're very variable in terms of its amount between or even within a mine or an individual mineral deposit. So therefore, I had to perform like many different experiments under different chemical environment with different chemical component to figure out, okay, what is the optimum amount of CO2 that I can extract from these mine waste material under different chemical environment or different chemical component that's going to give me like the maximum, right? So that's the key to my data, and it's the most important part is collecting the data and analyze it, basically.
Great. And so why is it important for you to share your data and your research?
Well, I'm personally really proud of my research. Just to say that I think it's an evolutionary research for the mining industry. It's a very new scope of idea for sure. And future work of my research involves that I will be focusing on creating a model or a characterization protocol to actually having like a mine company to come to us with their mine waste sample, and I can perform a few experiments on it, and I will be able to tell them, okay, so under this chemical environment, with these chemical components, you can basically capture or utilize this amount of CO2. So this is what I'm trying to achieve, and then I hope this is going to be a foundation in the future for the development of carbon capture in the entire mining industry. Because right now, I think the world is moving towards like a more environmental friendly society, and we're trying to create this idea of using carbon, reduce carbon emission, or like reduce greenhouse gas effect and stuff. So I'm really hoping that the mining industry can actually take a step forward as well and think about the idea of mining for the environment.
Yes, that's awesome.
Yeah.
Thanks for joining us today, Xueya.
Yeah, no worries. Thank you very much for inviting me.
Of course. Once again, this is the Data Speaks competition at RFG 2018, created in partnership with Sequent. You can watch the videos on YouTube or Twitter, #CDataSpeak.